Okay, so I'm going to mainly go over right now section 7.4, these problems here, because I know these were the more difficult ones, and I know you all had questions about these. Okay, but I'm going to show you these notes I had written for the previous sections. That way, you have them, you can pause, you can look at them, things like that, and if you have questions, you can let me know. I'm trying to set up a Zoom class so that you can ask me questions live, because I know this is difficult, and I've been having troubles trying to make sure it was safe and secure and things like that. So, first of all, this is section 7.1 geometric mean. These are the notes I wrote down. Okay? And then it continues. Okay. Again, this is geometric mean as well. Okay? And I can go over these more in detail, but right now I wanted to get over section 7.4 because that one's the more important one, honestly. The Pythagorean Theorem and its converse. And I know these notes may be hard to read. Okay? Alright. This goes over number 16 on page 354, how to work it. And number 18, you have to use the distance formula 3 times. Okay? Alright, special right triangle, section 7.3. Again, there's 45, 45, 90, 30, 60, 90 right triangles. And they follow those patterns like I had showed y'all in class. Now, section 7.4 was really where I left off with y'all in class. Okay? And I'll go over these notes, and then I'll start working some of the problems from the book. Okay? And you will see the answers because the only book I have is my teacher's edition. They have the answers in the book, so when I show it to you, they're there. Okay, but I will be putting up a multiple choice test once we get through this stuff. Then we'll go through that. So I'll go through that first, though, with you. 7.4 trigonometry. The following is specifically only right triangle trigonometry. There has to be that one right angle in the triangle. It does not work. Or these things don't work unless you have that. But there's other special rules you have to follow, which we'll get into. Okay? So this is the triangle I'm using right here. So ABC, triangle ABC, with side A, little a there, is opposite angle A. Okay? That's opposite the angle. This little side B is opposite B, but it's also adjacent to angle A. It's next to. Adjacent means next to. Okay, so when you're doing trigonometry and right triangle trigonometry, it depends on which of these two, not the right angle, the other two angles you're looking at. That will change whether it is opposite or adjacent, these sides. It does not change the hypotenuse. The hypotenuse is always that longest side, the side opposite the 90-degree angle. It's always that longest side. That's always the hypotenuse. All right, now, if we're looking, and this little symbol right here, it's a little hard to see there, I see that, but, and it's a little hard to see that as well. That's theta, okay? That's the variable theta. So it just means there's an angle here. And specifically, it means what measure it is, but we're not going to talk about that just yet, okay? So here, if this is the angle I'm looking at, this side here is opposite angle A. Okay? It is, this side here is adjacent to angle A. Okay? Adjacent means next to, so this is the side, AC, is next to angle A. BC is opposite angle A. It's important to understand that. Now, if I was looking at this other angle here, these two would be flipped. This would be opposite to angle B. This would be adjacent to angle B. Okay, so it all depends on whether you're looking at this angle or this angle as to what is opposite and what's adjacent. Remember, adjacent means next to. Okay, next to that angle. All right, so there's 3 trigonometric ratios: sine, cosine, and tangent. And they're always dependent upon which of the two non-90 degree angles you're looking at. Okay? So, and I just said it there again, in the above image, theta is that little variable. It's a Greek letter, theta. It's a variable for an angle. It just means what measure is that angle. Okay? It also, therefore, represents what angle we're looking at. Okay, so if the theta is there, that's the angle I'm looking at. If the theta were over here, that would be that angle I'm looking at. Okay? Now, looking at angle A, theta equals angle A. Okay? Sine of angle A. Okay? Remember, these are always of something. They're always of an angle. They cannot be not with an angle. Okay? And what you're going to see is it's not times. See, this is sine of angle A. That does not mean sine times A. Okay? It's not a multiplication that's happening here. This is a special function. It's not addition, subtraction, division, or multiplication. These are special functions. Okay? It's not multiplication between these two things. It's sine of A. Okay? Sine of any angle is opposite over hypotenuse. And that's opposite of angle A. Hypotenuse is always a hypotenuse. So here, if we're looking at this triangle, opposite over hypotenuse. Okay? Opposite over hypotenuse. Oh, you can't see that. I'm sorry. Okay? Opposite over hypotenuse. Those distances over each other. Opposite over hypotenuse. So here, that would be BC over AB, which is just A over C. Okay? Cosine, COS, of angle A is adjacent over hypotenuse. Adjacent over hypotenuse. So what's adjacent to angle A? Side B there. Okay? Little b over little c. Little b over little c. Okay? And then tangent of angle A, tan of A, is opposite over adjacent. Okay? Of that angle. So opposite of that angle over adjacent of that angle. A over B. Okay? And note when I use these notations here, HYP means hypotenuse. OPP means opposite of the theta, the side opposite it, and ADJ means the side adjacent to that angle. Okay? So that was if I was looking at angle A as my theta. Now what would it be if I looked at angle B? Okay? So sine of B here, these right here, is opposite of angle B. Which one's opposite angle B? Well, that would be this angle here. So what side's opposite that angle? AC down here, little b. Okay? And if you notice, the little b is always opposite the big B. Little a is always opposite the big A. Little c is always opposite the big C. That's the notation I'm going to use. Okay? May not always be the case, but you can definitely use their endpoints to determine these. So remember, little c is the side AB. Okay? Little c means the distance between A and B. Okay? So, sine is opposite of B over hypotenuse. So that's B over C. Cosine of angle B is adjacent to B over hypotenuse. So which one's adjacent to B? A. Little a here. A over C. And tangent of angle B is opposite of B over adjacent of B. Opposite of B over adjacent of B. B over A. Okay? This is how I've always been taught how to remember it. This is the easiest way to remember it as far as I've ever been able to know. So, ka, toa. S-O-H. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. To remember which is over which for each trig function, it's like kind of like a Native American name almost. Like Pocahontas, so, ka, toa. Okay? So, S-O-H. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay? This is the basics of right triangle trigonometry. How do we use this? Okay? So, here I have a problem worked out for an example. Here we have a 3, 4, 5 right triangle, and yes, it is messy. Okay, let me zoom in a little bit. Okay, so it says find sine of angle A, cosine of angle A, tangent of angle A, sine of angle B, cosine of angle B, tangent of angle B for the following triangle. Okay, so find all three trig functions of each angle. Okay, so we're going to do one angle at a time. Now this is my triangle here. It's messy, I understand. 3, 4, 5. Remember, longest side's always the hypotenuse. Now which one we're looking at, which angle, depends upon, will change up which is opposite, which is adjacent. Okay, so if we're looking at angle A, this side over here is the opposite. Okay, this side over here is the adjacent. Okay, let me draw that a little bit. So for angle A, okay, if this is A, this is opposite. This is okay, and if this is the 90, this is the adjacent, and then this is the hypotenuse. Okay, so sine of angle A is opposite over hypotenuse. 3 over 5. Opposite over hypotenuse. Opposite over hypotenuse. Okay, 3 over 5. 3 over 5. Cosine of angle A. Cosine is adjacent over hypotenuse. Okay? Remember, so katoa. Okay? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So cosine of angle A is adjacent over hypotenuse. 4 over 5. Okay? Now tangent of angle A, tangent is opposite over adjacent. Okay? So opposite over adjacent, 3 over 4. 3 over 4. That's all it wants. It just wants that ratio. Okay? Now if we're looking at angle B, it switches which is adjacent and which is opposite. Okay? So if we're looking instead at, I'll redraw it here too. If we're looking instead at angle B, well now this is opposite, this is adjacent, and this is still the hypotenuse. So sine of angle B is opposite over hypotenuse. What's opposite for angle B? Opposite over hypotenuse. Opposite over hypotenuse. 4 over 5. Cosine of angle B is adjacent over hypotenuse. So that's 3 over 5. Okay? Adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent over hypotenuse. 3 over 5. Tangent of angle B. Opposite over adjacent. Notice it's just the flip. It is the reciprocal. If you're looking at the other angle, you flip the numbers basically for the tangent. Sine and cosine, not exactly like that. Okay. 4 over 3. Opposite over adjacent. Opposite over adjacent. Opposite over adjacent. 4 over 3. Okay. That's the basics of trigonometric ratios. Okay, it's not looking for the angle degree or anything like that yet. Okay, we're going to get to that. We're just looking at what ratio does each one represent. Okay, so next one. All right, using a calculator. All right, so you plug it in the angle after pressing the correct button. Okay, so for instance, cosine of 45 degrees. You hit cosine, the cosine button, and let me get my calculator to show you here. Now this isn't a graphing calculator. This is one of those calculators I have from the classroom. Okay, it's one of these. If you have, that's what you have, you can do it on this, that's fine. Okay? So, I want to do cosine of 45 degrees. Okay? Sine, cosine, tangent. Okay? That's what we're going to do. So it's cosine of 4, 5. Close parentheses. Okay, now you're going to have to round it. These are going, most of these, there's a few that aren't. There's a few special angles that aren't going to need to be rounded, but you're probably going to need to round it. Okay, so that's cosine of 45 degrees. Now notice, if if you can read that right here, closer, without the light. Focus. Light out the way a little bit. It says degree there. Your calculator has to be in degree mode. Okay? Now, okay, note, make sure your calculator is in degree mode. Alright? That means that this is degrees, it's not radians. That's the other way you could do it. There's the third way, but no one really uses that except for engineers. So radians, so if you're looking on here, DRG, that switches between degrees, radians, and that's gradients. Okay, I don't teach this one. If you need to know it, you can look it up if you want, but if you all have a class where you'll talk about that. Radians, I will go into eventually, but not right now. More likely I'll go into that in Algebra 2. Because I probably won't get to it this year. Okay, but it needs to be in degree mode, okay? Otherwise you won't get it. So like, let's say if it was in radians and I put it in that, and I tried that, it gives me something completely different, okay? It'll give you the wrong answer. You need to make sure you're in degree mode right now, okay? Alright. Okay. You will need to round to whatever the question asks you to, okay? Alright, so, and that's just all you do for that. So that would be for these questions right here. Use a calculator to find each value, round to the nearest 10,000ths. Okay, so for instance, sine of 6 degrees, sine of 6. So the nearest thousandths, so that's tenths, hundredths, thousandths, 10,000ths. Okay, so that'd be 0.1045. Okay, that's all you have to do for that. Again, these first 4 right here, that was that previous thing I showed you how to do each operation there. Now, looking down here, use the figure to find each trigonometric ratio. Express answers as fractions. Again, that's what we already discussed. It's just to separate the triangles here. Alright. So, using trig to find side length. Okay? That'd be like number 43 here. Okay? You're trying to find the length of that side. Alright, so here's an example. Here I have a right triangle. The length of this side is 4. The angle of that is 35 degrees. Now, I know what this angle is because it has to all add up to 180, right? So I can figure that out if I want, but I don't need to. I can just use this angle. This is going to be my theta. That's the angle I'm going to be looking at. So what sides do I have? Okay, I don't know the bottom, but I do know 4 is opposite 35, and x is the hypotenuse. Which trig function uses the opposite side and the hypotenuse? SOHCAHTOA. Sine of theta is opposite over hypotenuse. So that means that what's opposite? 4. It's opposite the 35 degrees. Hypotenuse is x, 4 over x. Opposite over hypotenuse equals sine of that angle. Okay, sine of that angle. So that's 35 degrees, sine of 35. You move as one unit. Okay, if you want to undo it, which I'm about to show you, you have to do something special. Okay, it's not sine times 35, it's sine of 35. It's very different. Okay, so I'm going to solve for x. Meaning I'm going to multiply both sides by x. Okay, and so that ends up canceling. And so then I get 4 equals x times sine of 35 degrees. Okay, then I divide both sides by sine of 35 degrees. Okay, and that cancels that. Okay, so I have x equals 4 over sine of 35. At this point, you got to plug it in. Alright? Alright, so what's 4 divided by sine of 35? 6.97 and I put 4 because I rounded it to the thousandths. It depends on what you're asked to round to. Okay? But I did round that answer. Okay? That's how you find a side. You figure out which two sides. You have to know one of the sides. You have to know an angle. Okay? And then you have to have your side you're missing. Okay? So compare the side you're missing to one of the sides you have, and use whichever trig function uses those two sides. Okay? This was my opposite and this was my hypotenuse of 35, so I used sine. Okay? Now, to find the missing angle, that's a little different. Okay? That requires you to use the inverse functions. They're actually, it's kind of hard to see, they're right above the sine, cosine, and tangent. You see sine, that little -1, cosine, that little -1, tangent, that little -1. That means inverse. Okay, it means the opposite of tangent, the opposite of sine, the opposite of cosine. It's what that means. So to undo a trig function, you use the inverse. Sine inverse, cosine inverse, and tangent inverse. So for instance, if sine of theta is opposite over hypotenuse, we know that. Alright, that means theta is sine inverse of that ratio. Okay? So for instance, this example right here, I have theta, and I have a 6, and this is an 8. I wrote these quickly, I apologize. Alright, theta, 6, and 8. This is the angle I'm looking for. Alright? I have opposite and I have adjacent. That means I'm going to use tangent. Okay? Opposite over adjacent is tangent of that angle. I need to find theta. Okay, so tangent of theta is opposite over adjacent. So tangent of theta is 6 over 8. But here's the thing. I need to undo that and bring it over here, and the way you do that is you do the inverse of the other side. Okay? That's what you're doing. So this is what's actually happening. You're actually taking the inverse of both sides. Okay? But what that does is that cancels that, leaving you with just theta. Okay, so how do I plug that in? Same way you did with the trig functions, alright? Make sure you're in degree mode still, okay? And so then you have to do the tan inverse. So you do second on this one, tan, which is usually what you're going to do in most calculators. And then you're going to do 6 over 8. Doesn't matter if you simplify the fraction or anything like that. You could have put 3/4. It's going to give you the same thing. Alright, and we get 36.869, depending on where you want to round to. Okay, so I'll just do the tenths, so that's 36.9, and that's degrees. That is the measure of that angle. Okay? That is how you find those missing measures. Now, that covers pretty much all of these problems right here. Okay, I want you to see how this looks. Okay, and I'm going to put the assignment, I'm going to put a worksheet. I'm going to post a PDF of a worksheet up on LMS. Okay, I want you to go over that. Don't worry too much about 7.1 through 7.3. Okay, if you posted something, I'm going to give you credit. Okay, let's work from here. Let's go through these. Let's try to figure this stuff out. Go back over these problems. Okay, here's all the answers except for a couple of them you can't see. Here, oh, down here, I'm sorry. That's the answers for 18, 19, 20, and 21. Okay? Look back at your problems. See if you can figure them out. And I will post this video on my YouTube channel, and I will continue to set up a time that you can meet me on Zoom, and I'll give you all the information, and we'll figure out the best way to get this to work. I know this is difficult. I appreciate you being patient with me, and I will be patient with y'all. Okay? Let's start with this then.